So we continue with group of 14 elements. Okay, this is the locations of group 14 element in the periodic table. Okay, group 14 elements consists of carbon, silicon, germanium, tin, and lead. Okay, the valential electronic configurations is ns2np2 with 4 valence electrons. Carbon is non-metal elements. Silicon and germaniums are metallites, while tin and lead are metals. Okay, the melting points of group 14 elements decrease going down the group. Okay, uh, carbon, silicon, germanium have a giant molecules molecule structure which is highly stable compared to giant metallic. Okay, the giant metallic bond is relatively weak due to the atomic size. Okay, for giant molecule, uh, each atom is bonded to 4 other atoms in a tetrahedral shape by strong covalent bond in a 3-dimension array. Therefore, okay, large energy is required to break the covalent bond. Okay, this is structure of a giant molecule. Okay, each atom bonded to 4 other electrons. Okay, the strength of the covalent bond decreases when going down the group from carbon to germanium. Okay, due to the size of atom increases going down a group. Therefore, okay, the melting point is decreases from carbon to germanium. Okay, for giant metallic, the melting point for lead is higher compared to tin. Older, older lead has a bigger atomic size. Okay. This is because lead has a more closely packed structure, okay, or fair center cubic structure. Okay, this is fair center cubic structure compared to compared to tin with tetragonal structure. Okay, the close packing of fair center cubic increases the strength of the metallic bonds in lead. Okay, for electrical conductivity, okay, going down group 14, the metallic character increases. As mentioned before, carbon is non-metal. Silicon and germanium are metallite, while tin and lead are metals. Okay. Um, in metal elements, okay, uh, there are delocalized electrons in the metals. Therefore, okay, electrical conductivity increases when descending a group 14. Okay, from non-metal elements to metal elements. Okay. Tetrachloride of group 14 elements. All the group 14 elements form covalent tetrachloride, okay, which consists of a tetrahedral shape, and the bond angles are 109.5 degrees. Okay, the group 14 tetrachloride exists as simple covalent molecules which held together by weak van der Waals forces. Okay, descending group 14, okay, number of electron increases. Okay, therefore the van der Waals forces also increases, and the boiling point increases when descending group 14. Okay, for group 17 elements, also known as halogens with a 7 valence electron. Okay, the halogens are odorless, tasteless, colorless, non-flammable gases, poor conductor of heat and electricity, have a low melting and boiling point. Okay, here is the location of group 17 in periodic table. Okay, uh, uh, with fluorine, chlorine, bromine, iodine, and acetylene. Okay, physical properties for the halogens. Halogen have a simple molecular structure of X2. Okay, for example, F2, F2, Bl2, Cl2. Okay, with a strong covalent bond. The halogen are toxic, oxidizing agent, highly reactive with high electronegativity, okay, with low melting and boiling point. Halogens are poor conductor of heat and electricity. Okay, fluorine is the most reactive of the halogens. Okay, reaction of halogen as oxidizing agents. An oxidizing agent is a substance that tends to oxidize other substances. Halogens act as an oxidizing agent by accepting two or more electrons from another substance. Okay, and as an oxidizing agent itself undergo a reduction reaction. Okay, consider these reactions. Okay, the oxidation process. Okay, the half reaction for oxidation process. Okay, the iodide ion. Okay, lose two electron. For reduction process, chlorine gas gain two electron, okay, to produce a 2 chloride ion. So in this case, chlorine act as oxidizing agent. Okay, when going down group 17, okay, the oxidizing strength of the element decreases. Okay, from fluorine to iodine. Okay, due to the increases of atomic radius and tendency to accept electron decreases. Okay, therefore, oxidizing strength of the element decreases. Okay, the most powerful oxidizing agent is fluorine. Okay, at room temperature, fluorine can oxidize water to oxygen. Okay, uh, and chlorine displaces aqueous bromide and aqueous iodide uh, to bromine and iodine. So in this case, chlorine undergo reduction process and become oxidizing agents. Okay, bromine can only displace the iodide ion from aqueous solutions. Okay, so bromine undergo reduction process and become oxidizing agent. Okay, iodine uh, only iodine cannot oxidize any of the other halide ions. Okay, last group in main group element is group 18. Okay, also known as noble gas. Okay, the valence electronic configuration for noble gas is Ns2 Np6 except for helium, just Ns2. Here is the location of group 18 element. Okay, consists of helium, neon, argon, krypton, xenon, and radon. Okay, the group 18 elements are odorless, tasteless, colorless, non-flammable gases. Okay, also poor conductor of heat and electricity, and have low melting and boiling point. Okay, the noble gases exhibit a stable octet configurations where the highest occupied electron level is complete. Okay, for example, helium has full outer shell of 2 electrons. Okay, the others of noble gas have a full outer shell. Also, have a full outer shell of electron. For example, neons. Okay, the highest occupied electrons levels. Okay, also complete with 2s2 2p6. Okay, the stable octet configurations giving the element great electronic stability and chemically inert or very unreactive. Therefore, noble gases also refer to inert gases. Okay, thank you.